I know, now we've got everybody back. Okay, so are there questions from the 6.1 journal that anybody wants to ask about? Sarah. All right, let's see. Page 274, number 13, which is a continuation of example 3. Let's see if that's the only one that I actually solved in my notes. No, I only did number 3. Okay. All right, so let's see. Okay, so we want to talk about page 274, number 13. Is that it? Okay, but to do that, we have to understand example 3, which says, estimate the volume of a solid sphere of radius 4. And so we picture the sphere, if its surface was generated, by revolving the graph of that part of the circle around the x-axis, partition it, yada, yada, yada. Okay, so number 13 says, use the slicing technique of example 3 to find the MRAM sums that approximate the volume of a sphere of radius 5. So I think in example 3, the way we got the sphere was to take the equation for the circle, right? And then rotate it around the x-axis? Yeah, okay. So let's start by, how do I write the equation of that circle that has a radius 5? How do I, what's the equation of a circle that has a radius 5? Right. So if I'm going to solve that for y, yeah. And I'm going to take the positive root because I want the part that's above the axis. And I'm going to rotate that around the x-axis, maybe not quite like that, but like this, so that I get my whole sphere. And I want to find, what I'm going to do is divide this into, again, not quite like that. If this is going to be my interval, for instance, I'm going to use MRAM. And what does MRAM mean? Okay, so I find the height of the rectangle by whatever the y value is in the middle of my interval. So if this is my interval, I'm going to go up here. Here's going to be my y value. And it's going to look something like that. Okay, and what's that shape really going to be? Yeah, it's really a cylinder. But it's not a weird conical cylinder, because I'm not following the edge of the circle. I'm making it a real cylinder and I'm stacking them together. So I'm not going to have, when I stack all my slices together, it's not really going to look like a sphere anymore. It's going to have all these little steps, but that's what I'm using to estimate it. Okay. So if we go back and look at example 3, then we were supposed to, and this is very similar actually to the to the problem we did in class with the nose cone, where we took the parabola effectively and rotated it around the x-axis, and then we broke it into all these cylinders, because what's the volume of a cylinder going to be? Sari, what's the volume of a cylinder? Yeah, I knew you knew it. Pi r squared h. So let's relate that back to our picture. On my blue cylinder here, what's going to be h? This is going to be h. You guys are a little freaky there. Okay, let's try this again. Where's y going to be? Tell me where to draw y between, or I'm sorry, r between. The x-axis and the height of my, for h? Okay, well, and that's why we have to, oh, okay. Yeah. Okay, so what's r gonna be? It's the y value. And I know that my y value is the square root of 25 minus x squared. Now the tricky part is h, which they call it delta x. Yeah, but I get that, but I wouldn't have, I mean, I'm looking at example 3, and I wouldn't have, like delta x should change, right? If I had, if n was equal to 10, okay, so if I took this, which goes from -5 to +5, and I divided it into 10 segments, what would h be? 1. Okay, so h is really 10 divided by n. Because the bottom line is I have this width here that's 10. Because my sphere has a radius of 5 that's centered at the origin. And I'm going to divide that into n subintervals. And so the width of the subinterval, or the height of the cylinder, is going to depend on how many subintervals I have, how many n, what my n value is. So I think we won't do all of these examples, but we'll do 1 or 2. So they tell you, okay, so let's do it this way. The first thing they tell you to do is to let n be equal to 10. So if n is equal to 10, then h is 10 over 10, which is equal to 1. Right? You with me? Which means that v is pi r, which is the square root of 25 minus x squared, that whole thing squared times 1. So that's what you want to put in your calculator for y1. And then yeah, and then what would a be? -. A is my lower limit, right? Yeah, I think you're going to go -5. B is going to be 5, and the number of sub-ints is going to be 10. So try that and see if you get what's in the back of the book. Okay. Can you come during lunch today? Come during help because Priya needs it too and she's coming during help. Okay, and then I'll do it once. Or if you can stay third period, apparently we're moving over to the shoebox and doing AP physics problems. So if you can stay for third period, we can, because Miss Basilia has a class in here for third period. We have physics fourth period. Third period is just, Sari emailed me and she needed help. Somebody else. So yeah. Yeah, literally the FBI's coming. Fifth period. Yeah, I think they're going to be here fifth period. They come for Scientists for Life. Yeah, anybody can come. Go talk to Ms. Winkowski. Okay, what's the answer? Focus. How did you get an answer? Oh, it's Sari's answer. All right, so MRAM, right? Because they said to take the one in the middle. So what was it, Zoe? Okay. Is that what the answer is in the back of the book? Are there answers in the back of the book? There should be. Yeah. But let's try another one and just see if our way of dealing with H is correct. Okay. Because there's a little table in the back. So let's take, no. Let's take n equals 20 because that's the next value we're supposed to choose, right? In the problem. So that means that H is going to be 10 divided by 20, or H is going to be what? A half or 0.5. So now our V is going to be pi r squared, 25 minus x squared squared times 0.5, and that's what you're going to put in for y1. And then what do we get for MRAM for that? A is still -1, B is still 5. Casey, what are you drinking? Oh, okay. It looks almost purple. I could tell that it was Starbucks. I'm like, what is she drinking? No. Okay. then we don't understand something. What did you get? 2? Yeah, see, and it shouldn't. It should be double that. It should be 525 point something. Well, I wonder if there's something wrong with using the 2. But if there is, I don't understand why. So let me go get the solution manual.